Hey guys, so today we're going to learn about chemical reactions. We're going to look at evidence of a chemical reaction, and then we're going to look at how to balance chemical reactions. Please make sure you have a periodic table out, you have your polyatomic chart out, and just make sure you remember you can pause me at any point to make sure you know what's happening, okay? So, the first thing you need to know is about combustion reactions. Combustion reactions are a subcategory of oxidation reduction reactions, which we'll talk about at the end of the slides. But this is when electrons are transferred from one substance to another. For now, after you've written that down, I also need you to write down the generic equation for a combustion reaction. So just remember that combustion reactions, generally when you think of combustion, you think about fire. Okay, fire always needs oxygen, and because fire is hot, when we have water coming out of the reaction, it comes out as a gas because, again, fire is hot. So please make sure you write that generic equation that I wrote at the top. Make sure you write that they're oxidation reduction reaction, which is when electrons are transferred. All right, so here we're just talking about laundry detergent, soap in regular water versus soap in hard water, and how they kind of leave residue on clothes and even like pots and pans, things like that from the dishwasher. So the next thing I need you to write down is evidence of a chemical reaction. There are different types of evidences of chemical reactions. This specifically is for things we cannot see. So this we could see in a reaction, or we could see if we could see the particles, but otherwise these are not things that we can visibly see. So one of those things is when atoms combine with other atoms to form compounds. When new molecules are formed, when the original molecules decompose. Remember that means to break down. Y'all should have learned that in biology. So when the original molecules break down, that's evidence of a chemical reaction. Or when atoms of one molecule change places with atoms in another molecule. So these are just different ways reactions happen, and we can see them in a chemical reaction. We will talk about the different types of reactions in part 3. These are evidence of a chemical reaction that we can observe. So color changes. Please remember it is a change of color, not just the presence of color. And I do want to be clear, food coloring is not a chemical reaction. The dye is already a color, and so that's what we're using. Formation of a solid in a previously clear solution. So it could be like particles at the bottom that you can physically see, or that it was clear and now it looks cloudy. And so that is a formation of a solid. Formation of a gas when you didn't have one before. This is not when we're heating. When we're heating, the gas is from the heat, not from the reaction. This is specifically, I put a substance into a beaker of some kind of liquid and it bubbles. Emission of light. This is like a glow stick, and you can see in the picture it's a glow stick. But you know, when you have to crack a glow stick, when you do that, you hear a slight crack. That's because there's a glass tube inside the glow stick that releases the substance inside the tube, and they react, and when those two substances react, they give off light. And then either the emission, which is giving off, or the absorption, which is taking in of heat. Okay, sometimes reactions, when you conduct them, they will feel hot or they will feel cold. This is what we're talking about. Absorption or emission of heat. So here in this one, we're just looking. You can see here, this is our Alka-Seltzer tablet. When you put it in water, it kind of fizzes and bubbles. When that happens, it's creating a new substance. Solid formation is next. That is when we mix two liquids together. Y'all, they don't have to be clear, but notice the color does change from yellow to red when we mix them. Also, there's a precipitate in there, which is a solid that formed. Please, please, please do not be fooled when you're heating up liquids. They will bubble when you heat them, but that is not a chemical reaction. Remember, physical changes are when we change states of matter, and in this case, we're going from liquid to solid. Okay. In the end, though, the only thing that we can be for sure of is when we do see a chemical reaction that we know that they changed into different particles. So here we're just going to go through and decide, are they chemical or not? Ice melting. Remember I said that state changes, so going from solid to liquid, that's just physical. So A is not chemical. That's just a physical change. B, we have electric current passing through water, and it results in forming hydrogen and oxygen gas. Now that is chemical. Okay, it broke from water into hydrogen and oxygen. Iron rusting, that is also chemical, y'all. It's always been chemical. And then bubbles forming when a soda can is opened, that's physical. Those bubbles were already in the soda. It's not new bubbles, it's just them coming out of the liquid. All right, I'm going to give you a minute to look at those, and then we're going to go through them. Okay, so anytime it says burning, please keep in mind that the word burning means fire, and normally if a fire is involved, it is a chemical reaction. Butane burning is a chemical reaction. Butane evaporating, however, is not. Evaporation is from liquid to gas. That is a physical change. Wood burning, again, you need to think about, can I get it back? No, once I've burned wood, it's gone. It's now ashes, or it's gone. Okay, it definitely changed, it color changed, even if it didn't turn into ash, things like that. Subliming, dry ice subliming, that is from solid to gas directly. That is a physical change, not a chemical change. Okay, next thing you need to remember, reactants are on the left. So I'm going to write reactants of the arrow, and products are on the right of the arrow. Now, this was something that you should have seen in middle school. I know middle school was kind of crazy for 8th grade because that was the year of COVID, but still, you should have seen this in middle school. You do need to write down all of these, okay? Y'all, gas is G, liquid is L, S is solid. Those make lots of sense, and for the most part, y'all are okay with that. Aqueous means it dissolved in water. Okay, that's what AQ means. That does not mean it's a liquid. It means the particles are dissolved in the water. Kind of like when we have salt water, those salt particles are dissolved in the water. Okay, so here you can see we went from one combustion reaction to a combustion reaction that had the states of matter present. Now, I do want you to keep in mind, y'all, Mastering Chemistry is up. It is long, and it is long because you have to type out these reactions, so you need to make sure you leave enough time that you can do it all and not be stressed out. So now we're to balancing. The biggest thing with balancing is you have to count each element on both sides, okay? So here I've got 2 oxygens. On this side, I have 3 oxygens. So that is clearly not balanced because they have to be equal on both sides of the reaction. Also, hydrogen is not balanced because I have 4 on this side, but on the product side, I only have 2. So I do need to balance this reaction. It is not balanced. So to balance an equation or a reaction, we need to insert coefficients. Remember, those are the numbers in front of the compound. They cannot be put, like if I wanted a number here just in front of the oxygen, you can't do that. You have to put it in front of the whole compound. Okay? Also, you cannot change subscripts. Subscripts are where they live based on either the name or the charges. They do not just appear out of nowhere, so you can't just add them. You only put coefficients in front, and when we do that, that means I times it by both of these elements that are in the compound. So here we are checking at the end. We always want to check once we put coefficients in. And everything is balanced. We have the same number of each atom on both sides. Okay, here's a particulate view. Remember, Mastering Chemistry does like particulate views, so you may see that. These are the steps to writing a balanced equation. Step 1 is to write a skeletal equation. That's just an equation that doesn't have any coefficients, but it's already set up. You may have to write them, and you will. You will have to today. You will have to on Mastering Chemistry. You will have to on test day. It is imperative that you review your nomenclature rules, which is naming, if you don't remember how to write formulas, because most of the time they're just going to give you a name. Okay. Number 2, you will balance metals before nonmetals, and this will make more sense as we go through. Okay, number 3, if an element occurs as a free element, that means it's alone on one side or the other, then that should be balanced last. That's because free elements are likely to appear in other compounds. So you want to make sure you do that one last because we're going to affect it as we go throughout. Last step, like in all things, you should check and make sure that the equation is balanced. Because if it's not, something's wrong and you need to go back and fix it. And please, please, please remember, you can only change the coefficients. You cannot change subscripts. You cannot put coefficients in the middle. Okay. So here, this is a skeletal equation, and it wants us to balance it. Notice it does have states of matter. Great. Okay, I would go ahead and write this equation in your notes. And below it, I'm going to write what we have. Okay, I am going to write SO4 as one unit. Recall that polyatomic ions are whole units. That's one unit. This is one unit. So if they're the same on both sides, we don't need to split them up into sulfur and oxygen. We just leave them as a unit. Okay, at this point, we count the atoms. So aluminum on the reactant side has 1. Aluminum on the product side has 2. So I will have to balance that one in a little bit. Hydrogen has 2 on the reactants and 2 on the product side. So right now, hydrogen's good. We don't need to do anything with it. This is where it gets a little tricky. Okay, there is 1 sulfate. But on this side, I have 3 sulfates because there's a number outside of what I circled. So first I'm going to do aluminum. In order to make this 1 into a 2, I need to multiply by 2. So I'm going to put a 2 there. That fixes my aluminum. Now I need to focus on sulfate, which is my other problem area. Okay, again, we can only multiply. I'm going to go ahead and multiply this by 3 to get 3. I put a 3 in front. At this point, this distributes to the hydrogen as well because it's in front of the entire compound. So you need to make sure you remember that because this is no longer 2, this is now 6. So in order to make the 2 on the other side a 6, I need to multiply hydrogen over there by 3 because it's 3 times 2. At this point, we are balanced. You do need to go back and check. Okay, so it's going to walk us through it. Again, at any point you can pause. So write a balanced equation for solid silicon dioxide and solid carbon. All right, we have silicon dioxide, and it says it's solid. And means plus, solid carbon. Okay, to produce, this means arrow. Notice, y'all, I am leaving space so I can put in coefficients. That is important. So this makes solid silicon carbide, just SiC, plus carbon monoxide is CO, carbon monoxide gas. Again, on Mastering Chemistry, you will need to be able to write the formulas based on the words. And if you can't do that, you need to review Chapter 5 naming rules. And then at that point, if you need help, you need to come in and ask, okay? So SiOC. I'm going to count everybody on both sides. On my reactants, I have 1 and 1 for my products for silicon. Reactants, I have 2 and 1 for oxygen on the product side. And then I have 1 and 2. I do want to note, you have to add them if they're on the same side. Okay, so I did add 1 carbon, 2 carbons. So, carbon is a single element. We're going to wait to do that one last. I'm going to multiply oxygen by 2, because then I have 2 on both sides. When I did that, I affected my carbon in CO. Now I have 2 carbons there, plus the carbon in silicon carbide. So now I have 3 carbons on the product side, not just 2, 3. So I need to multiply the carbon on the reactant side by 3. And now it's balanced. Okay, I'm going to write this one and you're going to balance it for me, okay? So we have solid chromium 3 oxide. Do not forget the 3 goes to the oxygen, but oxygen has a charge too. It's -2. So you can't forget that part. Solid carbon to produce chromium, solid chromium, and carbon dioxide gas. Okay, so at this point, I need you to balance this for me and then to check it. Okay, the biggest thing with this is that you realize oxygen and carbon are 2 and 3. The only number they can be that's a whole number to be equal is 6 by multiplying. So I have to put a 3 in front of carbon dioxide and a 2 in front of chromium 3 oxide. When that happens, I affected my chromium. Now I have 2 times 2, which is 4 chromium, so I need 4 on my product side. And then carbon is 3 based on my 3 carbon dioxides on my product side. If you're better doing it this way, that is perfectly fine. If you need to physically go back and count them like I did in the other 2 examples, please do that. Okay, I'm going to balance this one with you. And remember, this is a combustion reaction. It says that, which means I have oxygen gas, water. Wait, it does carbon dioxide first. Oops. So that's what we're going to do. So for now on Mastering Chemistry, you're not going to have to predict the products, but eventually you will. So you need to make sure you understand that all the stuff in a combustion reaction is gaseous except the hydrocarbon at the beginning. So if you're copying this down as we go, please use pencil. Okay, I have 8 carbons in my octane, so I need an 8 here. I have 18 hydrogens. I need a 9 in front of H2O. Now we need to go back and count all of our oxygens. So here I have 16 O's and I have 9 O's. Okay, my oxygen cannot be made into a 25. So at this point, I erase everything, I start over, I put a 2 in front. This is just for combustion reactions. You need to start with a 2 in front of that hydrocarbon. So now this carbon is 16. This is 18. So now I have 32 O's plus 18 O's. That is 50 oxygens, y'all. So in order to be 50, this needs to be 25. This is for all combustion reactions, put a 2 in front. If everything is even in the end, you can divide. But for now, that's not what we're doing. For now, just start with a 2 in front, because then you don't have to go back and do it again. Okay, I'm going to write this one. This is a combustion reaction, which means, remember, you need to start with a 2 in front. Okay, you balance it. and then we'll check it. 2 in front. That gives me 8 carbons. That gives me 20 hydrogens. I've got 16 O's here, plus my 10 oxygens. So this needs to be 13 to equal 26 oxygens on the reactant side. Okay, we did already do this one, so I'm going to skip it. This was the first example we did. This one, I want you to try the entire thing. I want you to write the formula. I want you to write the states of matter. I want you to balance it once you have your reaction. Whole shebang. Also, here's the deal. Some of you didn't learn writing formulas. You have to know it for this chapter. It is imperative. If you do not learn it for this chapter, you still have to know it for the rest of the chapters. It is super common that they give you only names. So please, please, please make sure that you're doing that. You know how to do that. Remember, ionic compounds cross their charge. So like just to give you a hint. There's lead 2. Here's acetate from the polyatomic chart. We cross their charges. Once you have this written, hopefully you wrote it properly, we're going to go ahead and balance it. So my iodine is off and my potassium and acetate are off. That's it, y'all. I just put a 2 in front of both. We're good to go. All right, this is the last one I'm going to have you do. It does go ahead and give you the formula. Like for the whole equation. This is the skeletal equation. I want you to balance it. All right, hopefully you were able to balance it. If you were not, I'm going to go ahead and I'm going to balance it for you so you can see some properly balanced. Okay, so we balance our metals first. Metals are balanced. Then we look at our nonmetals. Okay, I see I need to put a 3 here. 3 chlorines. But that messes with my hydrogen. Now I have 3 hydrogens on the reactants and 2 on the product side. So this has to be a 3 and a 6 to balance out. Now my chlorine is unbalanced. I need to put a 2 here, which means I need to put a 2 there. If you have questions, please come to tutoring. Please send me a message on Remind. You have to learn this, okay? We will take a quiz on balancing. For now, it'll just be a quiz on balancing reactions that are already written like this one. Okay, there's another one if y'all want to look at it. You all have a great day.